Welcome to Lecture 2 for Chapters 3 and 4. Our focus today, or our learning targets, are to sketch the graphs of quadratic functions by accurately plotting the vertex, the y-intercept, and, if real, the roots, as well as identifying the double roots and describing their behaviors in equations and graphs. These learning targets need to be written in your notes. If at any time I'm moving through screens too quickly for you to write, or if you need to hear something again, you can always pause or rewind. So the first thing we're going to do is we're going to go ahead and sketch the graph of y equals x squared minus 3x plus 2. So we say sketch because not every single point on the graph is accurate, but the 3 points that should be accurate are the y-intercept, the roots, and the vertex. And again, if there are roots, the roots should be accurate. So let's go ahead and start by finding the y-intercept. So the y-intercept happens when x is 0. So in this case, if all the x's are 0, all that's left is 2. So that would be our y-intercept. Alright, I guess you all have heard Audrey now, so sorry about that. Okay, so now I'm going to go ahead and find the roots, although finding the roots in the vertex, the order does not matter one single bit. So to find the roots, this looks like something that I can factor. So you'll remember that we can find the roots through factoring or by using the quadratic formula. I personally think factoring is a lot faster, so if you know how to do that, which you should, I would explore that avenue first and then go to the quadratic formula as a last resort. Okay, so to factor, I have x squared. I get that by multiplying x and x together. I also have my c term equal to 2. 2 is a prime number, so the only two numbers that make 2 and multiply it are 2 and 1. Now you'll notice 2 is positive. So to get a positive in math, we either multiply a positive by a positive or a negative by a negative. Okay, so my signs in my binomials could either be positive or negative. But since this is negative in front of the 3, I know that these have to be negative because if they weren't, I wouldn't get a negative number for my b value. Alright, so now to find the roots, what I really need to do is make these equal to 0 because roots are defined as values when x equals 0, or when y equals 0. So when I do that, if I substitute 2 in for x, it makes the whole equation equal to 0 because 0 times anything is 0. And when I substitute 1 in for x, that 1 makes the second binomial 0. 0 times anything again is 0. So our roots are 1, 0 and 2, 0. Alright, so let's go ahead and complete the square now so that we can find the vertex. So the first thing we're going to do is we're going to move 2 to the other side of the equation by subtracting. Okay, so y minus 2 equals x squared minus 3x. So it's called completing the square because we are interested in making a perfect square. So as a reminder to do that, we take our b term, which is negative 3, and cut it in half. So half of negative 3 is negative 3 halves, and then we square it. So negative 3 halves squared is 9 fourths. So I've added 9 fourths to this side of the equation. What I do to one side, I do to the other. Alright, so my square has been completed. So all I'm going to do is I'm going to combine like terms and then simplify to get it into vertex form. So on this side, I end up with y plus 5 fourths equals, and then I'm going to factor this, x minus, because this is a minus, 3 halves. And since these have to be the same, x minus 3 halves. We went over how to do this in class, so I'm not going to explain this again. Okay, so now I'm going to subtract 5 fourths from both sides. And I'm going to condense this so that instead of having 2 of the same binomials multiplied, I have 1 that's squared. So I end up with y equals negative 3 halves squared minus 5 fourths. That means that my vertex is, what makes this 0 is the x. So when x is 3 halves, I end up with 0 here. When this is 0, all that's left is negative 5 fourths. So that is my vertex. Alright. So let's go ahead and get to graphing this. So basically all I'm going to do is I'm going to plot 0, 2, 1, 0, 2, 0 in our vertex. So I'm going to go over to a grid and I'm going to do that. So I'm going to start by plotting my y-intercept at 0, 2, at 0, 2, sorry again about Audrey, she's kind of in a finicky little mood. My roots are 1, 0, and 2, 0. Okay, and my vertex is at 3 halves and negative 5 fourths. So I plotted those, and now to finish my graph off, this is where the sketching part comes in. I'm just going to accurately, I'm going to sketch this to the best of my ability. Remember parabolas? Again, I'm really sorry about the baby crying. Parabolas are U-shaped, so make sure that you don't have a V at the bottom. It should look rounded. So there is the graph of y equals x squared minus 3x plus 2.